Hi, you guys. I want to take a look at HCAM number 4, chapter 18, and let's just take a look. This is that first chapter on steel, and I want to go over this section just quickly. 15.1 says that they want you to draw a wide flange, a 14 by 132 and a 14 by 43. So what they're asking you to do here, and I've already laid this out using Bluebeam Review, and what they're asking for here is they're asking for you to lay out a horizontal axis of symmetry. And so what I've done was I've just picked one of the grid lines here, and I've drawn a horizontal center line across here. So what they want you to do is they want you to refer to your text, and I'm looking at page 426, table 18.1, and on that page you should be able to find, you will find information on both of these beams. So the first one, and let me just scroll down a little bit here so that we can see, the first one is a W14 by 132. The second one is a W14 by 43. So the depth, which is nominal in this case, is 14. And you can kind of see I have my drawings here are not completely 100% correct. I'm close though. So you can tell by looking at these two that while they're both W14s, and those are wide flange 14-inch deep beams, the weight has an impact on the actual dimensions of these beams. So my 132 you can see is a little bit deeper, and the 43 is going to be shallower. And take a look at the mass between the flanges. You know, the flanges get wider and thicker the heavier the beam is. So the 132 pound per lineal foot beam is just going to show up massive. In fact, it's wider than it is deeper. The W14 by 143, if you go back and look at that one on table 18.1, you'll notice that the flange, or I'm sorry, the depth of the beam is actually 13.66 inches. And then if we go back up to the heaviest beam in that family, our overall depth is 14.66 inches. So I hope that this kind of gives you a better idea of what they're looking for. So they're just wanting you to draw an axis and then kind of lay things out on this grid. So each one of my grids is 1 inch in each direction. So I'm just gonna, I'll see if I've got, I'm going to measure this so that you can kind of see if you use these the grids, this should come up at 1 inch. Oh, it's 1 inch, but I screwed that up. Sorry about that. Edit, undo. So you can kind of see that each one of these grids is 1 inch. So let's keep moving through here. The next part of this assignment is, what is the weight of each W section? So I just explained that to you. In all cases, the W is going to be the type of section. The first number that you see is going to be the depth of the beam, and the second number is going to be the weight per lineal foot. So that's really the answer to that question. Which dimensions are equal between the two W sections? Are there any dimensions equal? Of course. If you take a look at page 425, figure 18.1, you will see the answer to that question. And then take a look at, for part B of this question, take a look at page 424 in your text for various hot rolled steel section shapes, and I'm going to let you guys draw those out and you can turn them in. I just wanted to do some of these. So yeah, what is the weight? So you're going to have to look for, try to find the weights of the C sections, and I think that those are in your text, but I'm not sure. If they aren't, let's open up a discussion on that and we'll see if we can't find them. I want to keep going here. I'm going to just kind of skim through this first section on here. So it says, using freehand sketches, illustrate 3 methods currently used to produce hollow structural sections. So I don't think that this, I mean, I'm looking at this thinking this is not necessary. They actually removed this from the text between the second and the third editions. The information is online, but from what I can tell, this looks like most of these shapes anymore are created through an extrusion process. So let's not worry about, you don't have to do 15.2. If you already have, great. If not, I wouldn't worry about it. So, sorry, cancel. Sorry about that. I'm in Bluebeam right now. So, using the document referenced in 15.2, sketch 3 different shapes of HSS produced by manufacturers. So there are different shapes of hollow steel sections that are tubes, and you know, one of them's a square, there's circles, there's rectangles. Those are probably the 3, and all those are going to be in your text. Now, when it comes to the largest and smallest sizes of square HS, Google steeltubeinstitute.org, and there will be about a 20-page document that comes up. And if you scroll through that, they list every possible size of HSS tube. So you should be able to find your answer on that document. Again, just Google that. Then it says list the thicknesses in which 9x5 HSS are available. You can find that in the same document on steeltubeinstitute.org or in your text. And I think that's going to be about it for that first section. So I hope this helps. And again, if you have questions related to these, the HCAM assignments, go ahead and post them in the discussion forum in this learning module. Okay, thanks.